Hello everyone, welcome to Aakruthi, Art of Mathematics, Simple Mathematics Classes. This is Relations and Functions, Class 3. I am Sudhir MK. In this class, I am going to discuss about functions, domain, codomain and range of a function. Please subscribe the channel for more video notification. First we see definition of a function. A relation f from set A to set B is said to be a function if every element of set A are related with only one element of B and it is denoted by f from A to B. So every relation is not a function. A relation from set A to set B is said to be a function if every element of A, that is all element of A, are related with unique element of B. That is, every element should have only one relation. So therefore, a relation f from set A to set B is said to be a function if every element of set A are related with only one element of set B. And it is denoted by f from A to B. So this is notation for function. A function is denoted like this. It is f from A to B. So we consider one example. Suppose you consider set A with 1, 2, 3 and set B with A, B, C. So now here consider a relation 1 related to B and 2 related to A and 3 related to B. Now here all the elements of set A have only one relation. So 1 related to B only, 2 related to A only and 3 related to B only. So here all the elements of set A are uniquely related. So therefore this relation is a function. So don't see the second set, see only first set. So here all the elements of set A are related with unique elements, are related with only one element. So therefore this relation is a function. Next, consider one more example. Consider set A with 1, 2, 3 and set B with A, B, C, D. Now 1 related with B, 2 related with C, 3 related with A, also 3 related with D. Now this relation is not a function since 3 is related with 2 elements. So 3 is related with A, also 3 is related with B. So this relation is not unique. Therefore this relation is not a function. So this relation is not a function since 3 is related with 2 elements. So this relation is not a function. Let's consider one more example. Suppose you consider set A with 1, 2, 3 and set B with A. So now here 1 related with A, 2 related with A and 3 is also related with A. Now here all the elements of set A, have only one relation. So therefore this relation is also a function. So this relation is a function since all the elements of a set are uniquely related. So they have only one relation. So therefore this relation is also a function. Let's consider one more example. Suppose you consider set A with 1, 2, 3 and set B with AB. Now here 1 related to A and 3 related to B. Now this relation is not a function since 2 does not have any relation. Here all the elements of set A does not have relation. So here 2 does not have any relation. So therefore this relation is not a function. So since here 2 does not have any relation, this relation is not a function. So definition of function: a relation f from set A to set B is said to be a function if every element of set A are related with only one element of B. Now here important is every element of set A. So every element of set A is related with unique element, that is only one element of B. So here every element of set A are related with unique element, that is only one element of set B. Then only that relation is called as function. You consider a function f from A to B, 1 related to C, 2 related to A and again 3 related to C. So in this function f from A to B, set A is called as domain, that is full first set is called as domain of the function, and set B is called as codomain, the full second set ABC is called as codomain, and set of images are called as range. Now here images are A and C only. The set containing A and C is called as range of the function. Now here domain is set 1, 2, 3, codomain is set A, B, C and range is AC. In a function f from A to B, full first set A set is called as domain, that is here 1, 2, 3 is domain, and second set B is called as codomain. Now here set A, B, C is codomain, and images. So here A and C are only images and set of images is called as range. Now here A and C is only images, so therefore set AC is called range of the function, and range is always subset of codomain. So here AC is a subset of ABC, so therefore range is a subset of codomain. So next we see definition of domain, codomain and range of a function. Let f from A to B be a function. Then the set A is called domain and set B is called as codomain and set of all images are called range of the function. So here first set is called domain, second set is called codomain and only set of images are called as range of a function. Next, consider one example. Consider set S with Bobby Deol, Abhishek Bachchan and Sunny Deol. Now here we have set S with Bobby Deol, Abhishek Bachchan and Sunny Deol. You consider one more set F with Amitabh Bachchan, Akshay Kumar and Dharmender. Now here we have set F with Amitabh Bachchan, Akshay Kumar and Dharmender. Now consider a relation, son of. Consider a relation from S to F, it is son of. Now first we draw this relation. Now here set S is with Bobby Deol, Abhishek Bachchan and Sunny Deol. And set F with Amitabh Bachchan, Akshay Kumar and Dharmender. Now here relation is son of. Now here relation is son of. We know that Bobby Deol is son of Dharmender and Abhishek Bachchan is son of Amitabh Bachchan and Sunny Deol is son of Dharmender. Sunny Deol is son of Dharmender. Therefore here Bobby Deol is related to Dharmender. Abhishek Bachchan is related to Amitabh Bachchan and Sunny Deol is related to Dharmender by the relation son of. Now here all the elements of set are related with only one element of the set F. So therefore this relation is a function. So this relation is a function, and in this function the first set is called as domain and second set is called as codomain, and set of images are called as range. So here Amitabh Bachchan and Dharmender only belongs to range. In this function F from S to F, domain is the first set. Domain is set containing Bobby Deol, Abhishek Bachchan and Sunny Deol. So here domain is set containing Bobby Deol, Abhishek Bachchan and Sunny Deol. And codomain is second set. Second set containing Amitabh Bachchan, Akshay Kumar and Dharmender. So it is second set containing Amitabh Bachchan, Akshay Kumar and Dharmender. Now here range, it is set of all images. So here Amitabh Bachchan and Dharmender are only images. So therefore range is Amitabh Bachchan and Dharmender. And here range is set containing Amitabh Bachchan and Dharmender. And range is always subset of codomain. So range is always subset of codomain. So in this function, first set is domain, second set is codomain, and only images are range. And range is always subset of codomain. Consider a function F from A to B, and here x related to y. So if f is a function from A to B and xy belongs to f, that is x related to y under the function f, and f of x equal to y. So here y is called image of x under the function f, and x is called a pre-image of y under the function f. Here x is related to y, so we write f of x equal to y. So we write f of x equal to y, and y is called as image of x. So here y is called image of x and x is called pre-image of y. So here y is called image of x and x is called pre-image of y, and we write f of x equal to y. A function which has either R or one of its subset as its range is called a real valued function. In a function, if set of real numbers or one of its subset as range, then it is called as real valued function. If its domain is also either R or a subset of R, then it is called as real function. If in a function, domain is also set of real numbers or subset of real numbers, then it is called as real function. So real valued function and real function. In real valued function, range is R or subset of R, and in real function, domain is set R or subset of R. So next we see some functions and their graphs. Now we studied different types of functions. First function, it is identity function. Let R be the set of real numbers. The real valued function f from R to R defined by f of x equal to x for all x belongs to R is called identity function. That is f of x equal to x only. That is each element related to itself. Then it is called as identity function. That is f of x equal to x only. So f of 1 is 1, f of 2 is 2, f of 3 is 3, f of 0 is 0, f of minus 1 is minus 1. That is every element is related to itself. This type of function is called as identity function. For identity function, domain, codomain and ranges set of real numbers only. So here domain, codomain and ranges set of real numbers. Next we say graph of identity function. So identity function is given by y equal to f of x equal to x. So we can write y equal to x. Now we take some values for x and y. When x equal to 0, y is also 0. When x equal to 1, y is 1. When x equal to 2, y is 2. When x equal to 3, y is 3. That is each element related to itself. So we draw the graph. We take x and y axis. When x equal to 0, y is also 0. When x equal to 1, y is 1. When x equal to 2, y is 2. When x equal to 3, y is 3. When x equal to 4, y is also 4. When x equal to minus 1, y is also minus 1. When x equal to minus 2, y is also minus 2. When x equal to minus 3, y is also minus 3. When x equal to minus 4, y is also minus 4. Joining all these points, we get a line like this. This is graph of identity function, and this graph is a straight line which passes through the origin. The graph of identity function is a straight line which passes through the origin. So graph will be like this. So this is graph of identity function. So next type of function is constant function. Let R be the set of real numbers. The function f from R to R defined by y equal to f of x equal to c. So that is y equal to c for all x belongs to R, where c is a constant is called constant function. Now here c is a constant and we write y equal to c, or f of x equal to c is called constant function. So c is a constant. Suppose it is y equal to 3, y equal to 5, or y equal to 0, or y equal to 2. All these are constant function. So here c is a constant, y equal to f of x equal to c is called a constant function. Here domain and codomain of f is set R and range of this function is set C. That is, this constant is only image. Therefore, the range of this function is set C. So range of this function is set C. So we see the graph of constant function y equal to 3. So here we take function y equal to 3. We take different values for x and we find value of y. So when x equal to 0, y is 3 only. When x equal to 1, y is 3. When x equal to 2, y is 3. So in constant function, if we substitute any value for x, we get same constant. For any value of x, y is 3 only. So it will not change. So therefore it is called constant function. For any value of x, y is always 3 only. So next we draw the graph. We take x and y axis. Now here when x equal to 0, y is 3. When x equal to 1, y is 3. When x equal to 2, y is 3. When x equal to 3, y is 3. When x equal to 4, y is 3. So when x equal to minus 1, y is 3. When x equal to minus 2, y is 3. When x equal to minus 3, y is 3. When x equal to minus 4, y is 3. For any value of x, y value is 3 only. We get all these points. When we join all these points, we get a line like this. So this is graph of y equal to 3. It is a constant function. So graph of constant function is always a straight line and parallel to x-axis. So graph of constant function is a straight line and it is always parallel to x-axis. The next type of function, it is polynomial function. A function f from R to R is said to be a polynomial function if for each x belongs to R, y equal to f of x equal to a0 plus a1x plus a2x square plus etc. an x power n, where n is non-negative integer and a1, a2, a3, etc. an are real numbers. Now here important, x to the power n should be non-negative integer. If you get non-negative integer in x power, then only it is a polynomial function. If you get any negative integer or fraction, it is not a polynomial function. So in polynomial function, x to the power should be a non-negative integer. And here a0, a1, a2, an are real numbers. Some example for polynomial function, f of x equal to 5x cube minus x square plus 2x minus 1 and f of x equal to 2x and f of x equal to 5 and f of x equal to x by 2 plus 4 and f of x equal to root 2x plus 3. All these are polynomial functions. Here in all function, x to the power is only positive integer. Now here f of x equal to 5, it's a constant function. Constant function is also a polynomial function. And here we have root 2 x plus 3. Now here root 2 is a real number and here x power is 1. So therefore root 2 x plus 3. This is also a polynomial function. Here we have x by 2 plus 4 and this can be written as 1 by 2 into x plus 4. 1 by 2 is a real number and here we have x power 1. So therefore f of x is x by 2 plus 4 is also a polynomial function. So this is also a polynomial function. All these are polynomial function. Now consider some other example. F of x equal to 3 root x minus 4, f of x equal to 2 by x minus 5 and f of x equal to 7 x to the power 3 by 2 minus 3x plus 2 are not polynomials. So these functions are not polynomials. So here we have x to the power 1 by 2. Root x means x to the power 1 by 2 and here we have 2 by x. So 2 by x can be written as 2 into x to the power minus 1 and here we have 7 x to the power 3 by 2. So here x to the power is 3 by 2. All these are not non-negative integers. Therefore these functions are not polynomial functions. Consider a polynomial function f from R to R defined by y equal to f of x equal to x square for all x belongs to R. So we take x values 0, 1, minus 1, 2 and minus 2. Then y value is 0 square is 0, 1 square is 1, minus 1 square is 1 and 2 square is 4 and minus 2 square is also 4. Now domain and codomain of this function y equal to f of x equal to x square is set of real numbers and range is set of all x square such that x belongs to R. So here range is square of all real numbers. Therefore for the function y equal to x square, domain and codomain is set of real numbers and range is square of all real numbers. So next we see graph of polynomial function y equal to x square. We take x value 0, 1, minus 1, 2 and minus 2. Then y value is 0 square is 0, 1 square is 1, minus 1 square is 1, 2 square is 4 and minus 2 square is also 4. So we draw the graph. We take x and y axis. When x equal to 0, y value is 0. When x equal to 1, y value is 1. When x equal to minus 1, y value is plus 1. And when x equal to 2, y value is 2 square 4. When x equal to minus 2 square is also 4. So therefore y equal to 4. When we join all this, we get graph like this. So this graph is called parabola. Graph of y equal to x square is in this shape and this is called parabola. Consider a polynomial function f from R to R defined by y equal to f of x equal to x cube for all x belongs to R. So consider a function y equal to x cube. And we take x equal to 0, 1, minus 1, 2 and minus 2. So then y equal to 0 cubed is 0 and 1 cubed is 1, minus 1 cubed is minus 1, 2 cubed is 8 and minus 2 cubed is minus 8. For y equal to x cube, when x equal to 0, 1, minus 1, 2 and minus 2, f of x, that is y value is 0, 1, minus 1, 8 and minus 8. Here domain and codomain is set of all real numbers and range is set of all x cube such that x belongs to R. Here range is cube of all real numbers. So range is cube of all real numbers. We draw the graph of polynomial function y equal to x cube and we take different values for x. It is 0, 1, minus 1, 2 and minus 2. Then we get y value 0, 1, minus 1, 8 and minus 8. We consider x and y axis. Now when x equal to 0, y is also 0. When x equal to 1, y value is 1. When x equal to minus 1, y value is minus 1. When x equal to 2, y value is 8. When x equal to minus 2, y value is minus 8. We join all these points. When we join all these points, we get graph like this and this is graph of y equal to x cube. So this is graph of y equal to x cube. So next function, rational function. A function of the form f of x by g of x, where f of x and g of x are polynomial functions of x defined in a domain where g of x is not equal to 0 are called rational functions. Any function of the form f of x by g of x, where f of x and g of x are polynomial function and g of x should not be equal to 0 are called rational function. Any function of the form f of x by g of x, where g of x is not equal to 0 is called as rational function. Consider some example for rational function. So here x cube minus 3x square plus 1 divided by 7x plus 5 is a rational function. 5x square plus x minus 4 divided by 4x cube plus 5x square plus 7x plus 1 is a rational function. 2x square plus 4x plus 5 divided by 4x square plus x minus 5 is also a rational function. So here rational function is defined only when denominator is not equal to 0. So here denominator should not be equal to 0. Consider a rational function f from r minus 0 to r defined by y equal to f of x equal to 1 by x. Now here we have to consider a function f from r minus 0 to r, that is set of all real numbers without zeros. It is non-zero real number. Non-zero real number to real number defined by y equal to 1 by x. So this is a rational function. Now we consider different value for x. When x equal to 0.5, y value is 1 by 0.5, it is 2. When x equal to minus 0.5, y value is 1 by minus 0.5, it is minus 2. So when x equal to 1, y value is 1. When x equal to minus 1, y value is minus 1. When x equal to y value is 1 by 2, 1 by 2 is 0.5. When x equal to minus 2, we get y equal to 1 by minus 2, it is minus 0.5. And when x equal to 0.25, y value is 4. And when x equal to minus 0.25, y value is minus 4. These are values of y for different values of x. Now here domain and range is set of all real numbers except 0. Here domain is set of real numbers except 0. Same type range is also set of real numbers except 0. And here codomain is set of real numbers. Next we draw graph of rational function y equal to 1 by x when x is not equal to 0. Now here we take different value for x, then we get y values like this. So we get y values like this and we draw graph for x equal to 0.5, y value is 2. When x equal to minus 0.5, y value is minus 2. When x equal to 1, y value is also 1. When x equal to minus 1, y value is minus 1. When x equal to 2, y value is 0.5. When x equal to minus 2, y value is minus 0.5. When x equal to 0.25, y value is 4. When x equal to minus 0.25, y value is minus 4. We get all these points for different values of x. We get values of y like this. We join all these points, we get graph like this. So this is graph of y equal to 1 by x when x is not equal to 0. So this is a graph of rational function y equal to 1 by x for x is not equal to 0. Here the domain is set of all real numbers except 0 and range is also real numbers except 0. For the function y equal to 1 by x, domain is set of all real numbers except 0 and range is also real numbers except 0. So next type of function, it is modulus function. The function f from r to r defined by f of x equal to x when x is greater than or equal to 0 and minus x when x is less than 0. For each x belongs to r is called modulus function and it is denoted by mod x. So this is symbol for mod x. Now here definition is f of x equal to x when x is greater than or equal to 0. So we have to write same number when x is 0 or more than 0. And we have to multiply the given number with minus when x is less than 0. That is if x is negative, you have to multiply that negative number by negative again. And we get minus of minus is plus. So therefore we get positive number for all modulus functions. F of x is x if x is greater than or equal to 0 and f of x is minus x when x is less than 0. If x is negative, we have to multiply that number by minus. So this is definition of modulus function. So for modulus function, domain and codomain is set of real numbers and range is non-negative reals. That is, we get real numbers including 0 and only positive reals. So including 0, all positive reals, we can write like this. That is non-negative reals. So we get only positive reals including 0. Therefore, for modulus function, domain and codomain is set of real numbers and range is non-negative reals. We consider example. Mod of 4 is 4 only. Since 4 is positive, we have to write same number. So mod of 1.4 is 1.4 and mod of 0.6 is 0.6 and mod of 0 is 0. If you get 0 or positive number, you have to write same number in modulus function. Now consider mod of minus 3. Mod of minus 3, minus of minus 3. So since number is negative, we have to multiply that number by minus. So therefore mod of minus 3 is minus of minus 3. The answer is plus 3. So mod of minus 3 is plus 3. And mod of minus 1. Since this number is less than 0, we have to multiply this number by minus. So mod of minus 1 is minus of minus 1. And minus of minus 1 is plus 1. So therefore mod of minus 1 is plus 1. Mod of minus 0.4 is 0.4. Mod of minus 23 is 23 and mod of minus 100 is 100. If you get positive number or 0, you have to write same number, and if you get negative number, you have to multiply that negative number by negative, so we get positive number. Mod function convert all numbers to positive number only. So these are some example for modulus function. Next we see graph of modulus function. Now here we take different value for x and we get value for y like this, and graph of modulus function will be like this. So modulus of 0 is 0 only, modulus of 2 is 2, modulus of 4 is 4, modulus of 6 is 6, and modulus of minus 2 is plus 2, modulus of minus 4 is plus 4, and modulus of minus 6 is plus 6, and we get graph like this. So this is graph of modulus function. So this is graph of modulus function. Now for positive value and negative value, we get only positive values. So graph will be like this. So this is graph of modulus function, y equal to mod x. Next type of function, it is signum function. The function f from R to R defined by f of x equal to 1 when x is greater than 0 and 0 if x equal to 0 and minus 1 if x is less than 0 is called signum function. F of x is 1 if x is greater than 0, f of x is 0 if x is 0 and f of x is minus 1 if x is less than 0 is called signum function. That is, if x is positive, you write 1, if x is 0, you write 0, and if x is negative, you write minus 1. So this function is called as signum function. For signum function, domain and codomain is set of all real numbers. So for signum function, domain and codomain is set of real numbers, and range is only minus 1, plus 1 and 0. So here we get only 3 values. It is minus 1, 0 and 1. Therefore range of the signum function is only the set containing minus 1, 0 and 1. Signum function f of x is also given by f of x is mod x by x when x is not equal to 0 and 0 when x equal to 0. We can define signum function like this also. F of x is mod x by x when x is not equal to 0 and 0 when x equal to 0. This is one more definition for signum function. We consider some example. Signum function is denoted by SGN and signum function of 0.4 is 1 only. So 0.4 is positive. For positive number, signum function is 1. So signum function of 13 is 1. So here 13 is positive. So therefore signum function of 13 is 1. And signum function of 25.9 is 1. And signum function of 1000 is also 1. If you get any number greater than 0, then its signum function is always 1. So for any positive number, signum function is 1. Now signum function of 0 is 0. For 0, signum function is 0 only. Now consider signum function of negative numbers. Signum function of minus 0.6 is minus 1. Since minus 0.6 is negative, signum function of minus 0.6 is minus 1. And signum function of minus 4 is minus 1. And signum function of minus 100 is minus 1. And signum function of minus 1000 is minus 1. So all these values are negative. So therefore signum function is minus 1 for all these values. So signum function of negative value is minus 1. And signum function of positive value is 1. And signum function of 0 is 0. Next we see graph of signum function. Now here we give different values for x, then we get values of y like this. For 0, it is 0 only. For positive value, it is 1. For negative value, it is minus 1. This is value of y for different values of x. Then graph of signum function will be like this. For x equal to 0, y value is also 0. So therefore for 0, it is 0. For any positive value of x, y value is 1. And for any negative value of x, y value is minus 1. So graph will be like this. For any positive value, x will be 1. For any negative value of x, y value is minus 1. For x equal to 0, y is also 0. Now here we have to write circle like this. This indicates that this point is not included. For x equal to 0, y is also 0. These 2 points are not included. We have to write circle without shading like this. So this is graph of signum function. So graph of signum function will be like this. The next type of function, it is greatest integer function. The function f from R to R, which gives the value of the greatest integer less than or equal to x, is called greatest integer function, and it is denoted by f of x equal to like this. So this is symbol for greatest integer function for all x belongs to R. We have to use square bracket to denote the greatest integer function. So f of x equal to square bracket x denotes the greatest integer function. In greatest integer function, we have to write greatest integer which is less than or equal to given number. We have to write greatest integer which is less than or equal to given number. And here domain and codomain of greatest integer function is set of real numbers and range is set of all integers. Here range is set of all integers. We consider some example. Suppose you consider 2.7. Greatest integer of 2.7. We have to write greatest integer less than 2.7. So it is 2. Greatest integer less than 2.7 is 2. Next, greatest integer function of 3.9. You have to write greatest integer less than 3.9 and it is 3. So greatest integer less than 3.9 is 3. Next, it is greatest integer function of 9.9. Greatest integer function of 9.9 is 9. Greatest integer less than 9.9 is 9. So next, greatest integer function of 15.1 is 15. Greatest integer function of 19.99 is 19. Greatest integer function of 0.4 is 0. Greatest integer less than 0.4 is 0. So greatest integer less than 0.4 is 0. So next, consider greatest integer function of 3. Greatest integer function of 3, it is 3 only. So that is greatest integer less than or equal to 3 is 3 only. Greatest integer function of 1 is 1 and greatest integer function of 0 is 0 and greatest integer function of minus 2 is minus 2. For integers, greatest integer function is same integer only. So next we consider negative numbers. Greatest integer function of minus 1.6 is minus 2. The greatest integer less than minus 1.6 is minus 2. It is not minus 1. Minus 1 is greater than minus 1.6. Therefore, greatest integer less than minus 1.6 is minus 2. And greatest integer function of minus 0.5 is minus 1. And greatest integer function of minus 5.9 is minus 6. And greatest integer function of minus 3.1 is minus 4. And greatest integer function of minus 9.9 is minus 10. All these integers are less than given number. So you have to find greatest integer less than or equal to given number. So next we see graph of greatest integer function. We give different value for x. So we get values of y like this. Greatest integer function of 0 is 0. Greatest integer function of 0.5 is 0. Greatest integer function of 0.9 is 0. And greatest integer function of 1 is 1. And greatest integer function of 1.5 is also 1. And greatest integer function of 2 is 2. For different values of x, we get values of y like this. So for different values of x, we get values like this. So next we see graph of greatest integer function. Graph of greatest integer function will be like this. Greatest integer function of 0 is 0 only. Greatest integer function of 0.5 is 0 only. And greatest integer function of 0.9 is 0 only. But greatest integer function of 1 is 1. Therefore, here we have to write one circle without shading. That is, this point is not included. For x equal to 1, y is also 1. Greatest integer function of 1 is 1. That is, greatest integer function of 1 is 1. And greatest integer function of 1.5 is 1. And greatest integer function of 1.9 is 1 only. And greatest integer function of 2 is 2. So again, this point is not included. Now here also you have to write circle without shading. So therefore, the greatest integer function of 2 is 2. So for x equal to 2, we get y is also 2. We get greatest integer function graph like this. So all these points are not included. And this graph is in the shape of step. And this function is also called as step function. So greatest integer function is also called as step function. And this graph is in the shape of steps. And all these points are not included. For x equal to 0, y is 0. For x equal to 1, y value is 1. For x equal to 2, y value is 2. For x equal to 3, y value is 3. So graph of greatest integer function is like this. So next consider two functions. So let f from x to r and g from x to r be two functions where x is a subset of r. So then we have f plus g of x is f of x plus g of x. That is, f plus g of x can be written as f of x plus g of x. So same type, f minus g of x can be written as f of x minus g of x. So that is, f minus g of x can be written as f of x minus g of x. So next, if k is any constant, then kf into x can be written as k into f of x, where k is any constant. Now here we can take constant outside. That is, kf of x can be written as k into f of x, where k is any constant. So next, f into g of x can be written as f of x into g of x. That is, product f into g of x can be written as f of x into g of x. So next one, f divided by g of x. F divided by g of x can be written as f of x divided by g of x when g of x is not equal to 0. We can write f by g of x equal to f of x by g of x provided g of x is not equal to 0. So that's all in this video. I will continue this chapter explanation in next video. Thank you for watching. Please like, share and subscribe the channel for more video notification. Subscribe my YouTube channel, Aakruthi Mathematics Classes. Thank you once again.